We're going to go over sinusoidal and sine wave functions. So we'll first talk about sinusoidal functions. We spoke about periodic functions, that are functions that repeat some type of pattern. So maybe like a heartbeat you'll see in a hospital does something like this, right? So it's periodic because it's creating the same pattern every time. Now sinusoidal will be periodic, but what it is it's a wave type of function, okay? And a lot of times these are represented by traveling in a circular motion over time. So you could think of it like a Ferris wheel, right? If we were trying to measure a Ferris wheel, which a lot of your examples are going to deal with, if you were on a Ferris wheel, and you started at the bottom, let's say at 0 in time, you would then travel halfway up, then to the top, then halfway again, and back to where you start. But because on these graphs, time will be constantly going forward, think of it like starting at the bottom, getting halfway up, getting to the top, halfway down, to the bottom, halfway up. So it's creating this sinusoidal wave, okay, traveling in this circular motion. This function here, y equals sine x, creates a sinusoidal wave. And we're going to talk about specifically this function. It's important for your ISU or your assignment you're going to do. One of the functions you're going to be creating a picture with. So, if we take a calculator out, we can actually solve for these. Now, I've written the x-axis very differently from what we had it from before. Okay, you remember we used sine in trig, and we're going to be putting degrees into this. So let me get a calculator out. So for instance, if I have 0 degrees and I hit sine, my answer is 0. So when x is 0 degrees, our y value is 0. The next major one I want to look at is 90 degrees. Okay. When we have 90 degrees, or when sine is 90 degrees, our y value is 1. Okay. So this is very important for you guys to know. There'll be some major, these are going to be the major points that we need to know for sine. 180. We're going to try 180. So when we have 180 degrees, sine is equal to 0 again. Okay? So when I plug 180 in for x, my y value is 0. When we plug in 270 sine, we get negative 1. So this is where we're going back below. Oops, thank you, that's 270. Okay, so we're going back below. Our y value is negative 1. And then at 360, who wants to estimate where they think it will be? 0. Yeah, that's right. Oops. 360 degrees, sine is 0. So if we were to represent that as kind of traveling in a circle, you can think of our 0 being the middle of a Ferris wheel, and we start right at the middle. So maybe like this would be our starting point. We then travel up, say it's a meter up, so here's our 1. And then we start coming back down to 0 again. We then go below 0 at negative 1 meter, or when we're at 270 degrees. And then finally that full rotation, which is 360 degrees, we're back at our 0 again. Okay? So what we're going to do is, now technically in between there are an infinite amount of points, and we can plug them in. For instance, just to get an idea of what this wave looks like, what would be halfway between 0 and 90?
45.
Yeah, so this line would represent 45. So let's try to get an idea of what 45 would be. So we have 45 sine is an awkward decimal for us. 0.707. So it's somewhere maybe up here. Okay. And because these tend to be symmetrical, our points that we follow are going to be like this. Okay? So what that means is we're going to get a wave. Now, we're not going to put every point in, but we're going to get a wave-type function. Now, this does not mean it's a straight line. It's very important that we have this circular type of wave to it. So where do we think 450 would be? That's right, we'll be at 1. So let's continue this pattern. This is an ongoing pattern. Okay, it'll continue as far as we can count degrees. If we were going backwards, negative 90 degrees. That's right, we'll be at negative 1. So our wave would continue down. Okay, negative 180. 0 again. Negative 270. That's right. 360. 0, and negative 450 is at negative 1. Okay? So this pattern continues. This is a sinusoidal function, and this is specifically sine. Okay? Now I want you guys, it's very important for your upcoming quiz, there are 5 major points you need to be able to plot. Okay? So our coordinates of 0 and 0, 90 and 1, 180 and 0, 270, negative 1, and finally 360 and 0. All very important that you guys remember for our upcoming quiz. Now there's actually specific points or terminology along this I want you guys to get used to.
Peak is the one over there.
Very good. So what would be the peak here?
The very top.
The very top, okay? And this peak repeats over and over again, right? So the peak is at 1, and this is considered our highest point. What's the lowest point considered?
What's it called?
Anyone know what it's called? No? The trough, that's right.
You want to just tell us the band and we'll tell you where it is?
Yes, that'll be perfect. So here's our trough. Now you could also think of these as like a max value and a minimum value. Except that, remember when we did quadratics, if we had a max or a min, it would only touch that point once. This is repeated. It will touch it many, many times, okay? It continuously gets to the max and to the min, okay? What would the range of this be?
What's the middle?
Wouldn't be the middle. A range consists of how far it is from the max to the min. So what would our range be here? How far does the range go? How far does this reach? How can we figure this out? Let's take the highest point and subtract the lowest point. Okay? So for our range, as an equation, think of it as taking the max, subtract the min. So our max was 1, and we subtract our min, which is negative 1. What is our range?
Let me think. 0?
No. 2. Okay? 2. Very important. Now, there's something related to the range. It's called the amplitude. And the amplitude is from the middle. And actually, you know what? Let's talk about what the middle is. There's also a name for that. The middle of an equation is called the equation of the axis. Okay? So that's an imaginary line running through the middle of this wave. So we're going to have to figure out how to calculate the equation of the axis. We'll do that one in green. Okay? So, equation of the axis. And we'll call it EOA for sure. For our EOA, we're going to take our max, subtract our min, and divide by 2. Sorry, plus. The other equation I'm about to teach you is minus. So we add the max and the min together, divide by 2, and that's going to give us the equation of the axis. So in this case, our max is 1. We add our negative 1, and that value will have to be divided by 2. What is 1 plus negative 1? 0 divided by 2 is 0. So the equation of the axis happens to be at the value of 0. Okay? In other words, you could say almost that there's a horizontal line where y equals 0. That's where it cuts right through it. Now, the other equation, which I had written backwards, is the amplitude. The amplitude is the distance from the equation of the axis to either the max or the min, the peak or the trough. Okay? So, in order to calculate amplitude, we take a very similar formula to this. Okay? We take the max, but we subtract the minimum and divide by 2. Okay? So I had those two mixed up for a second. So in this case, let's calculate our amplitude. The max value was 1. We subtract the minimum, which is negative 1, and we have to divide it by 2. What is 1 subtract negative 1? 2. And what is 2 divided by 2?
1.
1, that's right. So the amplitude, the distance from the equation of axis to the highest point, is 1, which makes sense, right? The highest point being 1. And the distance from the middle to the lowest point is a distance of 1 also. Okay, so the amplitude calculates the distance between these points.
Mitchell Nader.
All right, one last thing. Let's talk about the domain and range of this function, since it's going to be important for your ISU. Okay, we did calculate the range, but if I'm actually writing this in function notation, actually, let's start with the domain. That'll be a little easier. Because this is continuous, okay, what will the domain of this function be? That's right, x, element of all real numbers. Okay, it's continuous both ways. Nothing stops it. The range, though. Now, this is a continuous function, so we'll definitely have to start with y being the element of all real numbers.
The line thingy in the middle.
That's right. Such that, what are the restrictions?
Y is greater than -1 and less than 1.
That's right. The lowest point being the minimum, we'll start with that. Y is greater than and equal to, because it does touch it, so it is equal to it also, -1. And it is less than and equal to the value of 1. Okay, and I'll kind of write those as 1 so they look a little different than our such that. Okay, so that's the range of that function. Remember that it goes the highest point of 1, the lowest point of -1, and the domain is that it goes on forever.
That's right, Mitch.